This tutorial will give you a short overview of the hardware configuration structure, which consists of up to 6 different tabs. The hardware configuration can be considered as an interface between the CMC and the module of the test universe software. Remember that the different types of CMCs have different hardware features. The hardware configuration enables you to define how you want to use the test set according to your specific application needs. On the General tab, the user can define the test hardware to be used. In the combo boxes, under the Test section, the OMICRON Test sets are either displayed together with the serial number or can be manually set in offline mode. Click Details to change the voltage or current outputs configuration of the selected CMC test set. The illustrations on the right side of the configuration tables show how to connect the outputs with the selected configuration. The second section allows the selection of additional amplifiers, low-level outputs, or sensor simulations. Click on Details to set or change the configuration of your selection. Use the Import-Export feature to save or load the hardware configuration with the OHC extension. This way, the hardware configuration can easily be transferred to other test modules. The usage of the outputs and inputs can be defined in the following tabs. The number of available inputs and outputs will depend on how the test hardware has been defined in the General tab. All tabs are structured in the same way. Therefore, we can take the Analog Outputs tab as an example. The wiring matrix on the right allows you to indicate how the signals are connected to the CMC test set. This way, the first column assigns the output signal of the test module to the CMC test set output specified in the same line. This means that the voltage in phase A is assigned to the CMC output 1. The drop-down menu only displays the signals that a specific test module might need to conduct a test. The second column contains the names that will be displayed in the test module and test report. Finally, the labels of the test object connectors can be entered in the Connection Terminal column. If we have a look at the Binary Inputs tab, we can visualize the same structure, but with additional settings included. Most importantly, do not forget to indicate whether the signal is connected potential-free, which means dry, or with a specific voltage, which means wet. If the potential-free checkbox is cleared, both nominal range and threshold fields become available. Nominal range represents the nominal voltage of potential sensing binary or counter inputs, or the nominal range of analog voltage or current inputs. Threshold indicates the limit for potential sensing binary or counter inputs. Apply the same theory to configure the Binary Outputs tab. Finally, the Time Source tab permits the user to configure the trigger and synchronization setup for GPS, iRig-B, and PTP connections. Since the CMC test set can also work as an iRig-B generator, you can also use this tab to specify the timecode parameters.